And yeah, so first of all, welcome. And this is our very first Accelerate Grantee workshop. And we have the honor to have Draga and Talley to be our presenters to talk about dev tools and tips with building Napari plugins. So I hope you're going to find these sessions useful for your Napari plugin development, but of course, most likely you're going to have more questions afterwards, and feel free to continue the engagement. And also just to let you know, we're going to have this monthly workshop recurring for the next 4 or 5 months. And the goal of these workshops is to provide resources to Napari plugin developers to help make better quality plugins in general. And all these sessions will be recorded and shared afterwards. There might be some time delay, but we'll eventually share with the community. And for all the questions and feedbacks, of course, there's going to be live Q&A right after the talk. But if you have further questions, please use Zulip, Slack, ImageSC, any kind of channels to get in contact with us. I think Talley and Draga, they've been extremely helpful community members, and they will be happy to help you as well. So without further ado, let me stop sharing my screen, and Talley or Draga, whoever would like to start first.
So yeah, I'll take it away. So I'll just share my screen, but yeah, I'm going to mostly talk about testing plugins, and then Talley's sort of going to talk a little bit more about some other dev tools for plugins in general. So can everyone see my screen as it barely loads? Cool.
Yes, I wanted to ask if you accept that.
So I'm going to start with an introduction to unit testing. Just in general, it's going to be a quick introduction before we move on to actually talking about what you should test, and in particular, how you can check coverage of your tests. And then we're going to go through specific Napari plugin examples. So we're going to test a reader, and we're going to test a doc widget as well, because I suspect that the doc widget testing is a topic that people are particularly interested in. And then once we've done some local tests, we're going to show you how to run those tests on CI as well, so on GitHub workflows. And after that, Talley's going to take over, and he's going to go into some of the details about virtual environments, deploying your package once you've tested it, some code quality checks, and then some Napari specific best practices as well when writing plugins. So what is unit testing? Basically, it's checking that a unit, or a small indivisible section of code, behaves as expected under different input conditions. So in many languages, and in Python as well, this small indivisible section of code is usually a method or a function. And obviously, unless you're writing perfectly pure functions, and probably even then, the changes in input conditions can change the behavior of your code, and in particular, can change the behavior of your code in conjunction with other pieces of code. And so that's why it's important to test under different input conditions. And why test at all? Obviously, the first issue is that code does what you tell it to, not what you want it to do. So I don't think we're strangers to writing something and thinking it's going to do something, but doing something else. You probably didn't think of everything, right? There's always edge cases, and testing edge cases is one of the trickier parts of testing. It's not something that we're going to be able to cover in full today, but we're hoping to just give you a bit of an overview as it pertains specifically to Napari plugins as well. Testing is also important to protect against future changes. So, having a good understanding of exactly how things work at a certain point in time means later when you go and change the code, if some behavior that you weren't thinking of also changed as a result of those changes, tests can alert you to that. And you might just end up changing the test because the new behavior is desired, but it's probably better to do that explicitly than to not be aware of what's changed. And this is true for CI in particular, testing is important on different environments and on different platforms to avoid the ever-present, well, it works on my machine, so I don't know what's going on. And GitHub workflows are an easy way to test on different platforms, so like Windows, Linux, or Mac, and with different versions of Python, without having to go and purchase one of each of those machines. Now, the key to testing in Python in general is the assert keyword, whose syntax you've got written there. So you assert some Boolean expression, and then you have an error message for when that Boolean expression is false. And if that Boolean expression is true, then basically nothing happens, code execution just continues as normal as though that statement didn't exist. If the Boolean expression is false, then an assertion error is thrown. So an exception is raised, and you get your handy error message. So I'm going to go now to a demo of, what that looks like, and then we're going to move into plugins as well. Some of this is probably familiar to you, but I thought it was better to start from the start rather than halfway through. So let's say that you've got this simple function here. All it does is it takes a mark from, say, 0 to 100. And then if you got more than 50, you pass. And if you got less than 50, you fail. And so this is the function that we're going to test. And we're going to test it by writing two test functions. And the first one is going to be when we pass. And when we pass, so of course, we're going to call the function. And then we're going to assert that the grade is what we expect. And because we're testing here the passing case, obviously we're going to test that the grade is pass. And if it's not pass, then best practice is to write a very useful error message, something like expected mark to pass, but result was great. And then, of course, we'd want the same thing, but for failing, right? Because we want to test all options. And then it's pretty much the same. Copy pasting is a very common pastime with tests. We expect it to say fail, but everything else is pretty much the same. And then if we wanted to sort of run these tests, we could just call the function. Let's say we expect like 63 to 65 to pass, and we expect, say, 43 to fail. And then if we get to this point, that means no exception has been raised. So we're just going to print all passing. Right, so these are our first sort of super basic tests using the assert keyword. And we're in the same directory as that Python file, so I'm just going to run it. And that all passes, which is awesome. Now, if it was to fail, so let's say we're expecting to fail with 70, then we get the assertion error, expected 70 to fail, but result was pass, which is actually correct, but just wanted to show you what that looks like when it fails. And so that's like fine, I guess, but it's not particularly usable, right? Like anytime I'm going to want to try different marks, for example, I have to call this function specifically. I don't get much detail when the code is running, right? I just get like all passing. That's not necessarily super useful. And I don't really get any information about other tests when one of the tests does fail. And so making testing more convenient is where testing frameworks come in. And the testing framework that we're going to look at today is PyTest, which I'm just going to install with pip install PyTest. And testing frameworks help with a lot of things. They help with test discovery, right? So like crawling directories to find things that look like tests and run them. They help with providing convenience methods for writing tests. They make it pretty. So let's have a look at what testing that file with PyTest looks like. It's going to take just a minute to set up the PyCache, which is quicker. Oh, no, that is curious. Where are you finding mark? I wasn't prepared for this. Tally, if this is immediately obvious to
Show me the
you.
code again? You know, I'm not sure it works to use a thing. Yeah, a fixture name. You need to like give it a default or something, or not. Yeah.
So well, now that it's happened, I'm going to have to explain it. Mark might unfortunately be the name of a fixture in PyTest, and we are going to cover fixtures. But for now, I'm just going to rename this to mark underscore, and that should fix it. And for some reason, the rename didn't work. So I'm going to have to go through like a pleb and add underscores to everything. Let's try that again. Curious.
I'm not sure where you would like. PyTest is expecting something to provide that fixture, and I don't think it works like this.
Yeah, okay.
I'm not sure.
I swear I did it before, but
okay.
Oh no, I think no, okay, so that's a bummer. Let's do this. Parameters with PyTest, as we'll get into in a bit, are a bit trickier, but what I'm going to do here is just pass expected values. So let's see. If we run it like this, that should be fine. Okay, so what is this doing? It's going through the function, through the file. It's finding anything that's any method or function that is prefaced with a test. And it's running all of those things. So it's not running main at all. Indeed, because name was not main when we were running this, but it's finding all of these and it's running them. And they all pass. Now, if they were to fail, then PyTest is very good at tracing back the reason that things failed and showing you basically their values throughout the test execution. Now, in this particular case, it's really just saying to us, we got a pass there, but we were expecting to see a fail. But as we'll see in the more complicated examples, this traceback mechanism can be very useful. And another very useful aspect, or I guess tool that you get with PyTest is parameterization. So we've tested these functions so far just with a single value, but as we know, that's not exhaustive by any stretch of the imagination. And so what PyTest allows you to do is it allows you to parameterize tests. And so now we're going to give it back that pesky parameter, and we're going to put it back in the error message as well. And then we're going to give it the parameter name as a string. So we're going to parameterize the parameter mark with a couple of values, and we can pass those values in as a list. So we're going to try 65, we'll try, let's say, an 80, and then we'll try, let's say, a 50, because a 50 is kind of like an edge case where, you know, it's the lowest mark that's going to pass. And then if we run that, we should see that it now runs sort of 4 tests instead of just the 2 that we've written. This one still fails because we gave it 65, but more importantly, we see here that we expected 50 to pass, but the result was actually a fail. And the reason why that's happening is going to be obviously in our code. And if we look semi-closely, and probably some of you already spotted this, we said if mark is greater than 50, but we actually want greater than or equal to 50. right? So a mark that's 50 still passes. And then if we go back and rerun that, I think I fixed the other test as well. Now all tests are passing. Well, I spoke too soon, but now all tests are passing. So that's the basic idea of like the PyTest framework. It provides convenience tools. You can run, it can discover tests for you if you point it to a directory or to a file. So now let's look a little bit more closely at Napari plugins, which is kind of what we were here to do anyway. So we've got a plugin. This is my plugin. It is called Plugin Tests. And it's got a reader and a widget. Now the reader is actually just the cookie cutter NumPy file reader. Okay, so it just looks through, this is the Napari get reader sort of spec. It checks whether the path that you have passed ends with .npy. And if it doesn't, it returns none. But if it does, then it returns the reader function, which loads our data. So this is the first thing that we're going to test. And inside our module, so we've got the plugin tests module, and inside that module, we've got another module, and that module is _tests, which is a very common directory structure when you're writing tests. And then we've got a test reader.py file, which at the moment is empty. And we're going to populate it with some tests. Now, we're going to focus on, I guess, testing as much as we can. And we're going to focus on writing small, tests that, like we were saying, just look at one indivisible unit, right? So let's focus on testing the Napari get reader function. We see that sometimes it returns none, sometimes it returns a reader function. At a bare minimum, we want to make sure that if we pass in a path that does end with .npy, that gives us back a function that we can call. So the first thing I'm going to do is I'm going to import my Napari get reader function, and I'm going to import NumPy as well, just because I know I'm going to use it. And then I'm going to go test get reader returns callable. And in general, it's good to have your actual tests have meaningful names about what they're doing, but I'll leave that as an exercise to the reader. And then what I'm going to do is I'm going to pass in this parameter, tmp_path. And this is a PyTest fixture. You'll notice I haven't imported it anywhere, and I won't import it anywhere. It comes with PyTest. PyTest will sort of inject that for you when you run the tests. But what it provides for me is a temporary path that is not going to clog up my sort of, directory when I'm running my things, but it's going to be a temporary path that I can use to save some stuff that's going to get cleaned up automatically at the end of the test. So I'm not going to have to worry about like rm-rfing a bunch of random stuff that I have decided to write. And so the first thing I'm going to do is I need this file, right? I need this thing that I'm going to essentially be reading. And rather than getting it from somewhere, I'm just going to create it, right? So I'm going to first use the path to build a file, to build a file path. And then I'm just going to generate some data, right? I'm just going to be like np.random.range, and I'm going to make it small. And I'm going to make it small because at the moment, I'm not trying to test, hey, does this reader read like 20 gigabyte NumPy arrays? It's just, does this thing return a callable at all? I don't have any specific requirements for the structure of my data. It doesn't have to be integers. It doesn't have to be floats. If it did, then I would make sure to generate that. But for now, I just want to have some sort of file. And I'm going to save that. To this temporary directory. And again, you're not going to see this test file anywhere unless I guess you pause during test execution, because it will get cleaned up for you. And that's the beauty of the temp path fixture. There's also the temp dir fixture, which provides you like a full working directory. And you can use, I can't remember exactly which methods you can use, but you can use like .make dir and, other things like that inside temp dir. Okay, and so now comes the actual test, right? I have my file. I'm going to get the reader using this path. And then I'm going to assert that the reader is callable, right? Because I need to get a function out of this. And if I don't get a function, then, well, that's wrong. Here you would put your error message. I'm not going to, just in the interest of time, but let's see what happens. So I'm going to go into my root of my plugin. I don't have to go any further. And then if I just pytest dot, it's going to go through and discover all of the tests that it recognizes. It should recognize our reader test because it's in a test file and it's prefixed with test. And as you can see, that passed and it was all good. And if this was not .mpy, then it would fail because whatever we return isn't callable. And as you can see, it has again traced back that whatever reader returned, that callable of reader is false. And it's even sort of filled in the fact that reader at the time of that assertion was none, which is useful for us when trying to debug. So we've tested that. Now, the other thing that I want to test is like, okay, great, I'm getting this callable and it's a function. Does this function actually read my data? And this, I guess, is not like a super unit test. It's, I guess, more of a round trip test, but we'll allow it anyway. And what I'm going to do is test reader round trip. And so here, I'm going to want to write this data again. And instead of copying it, I'm going to, because potentially I'm going to write like 100 tests. Maybe I'm going to want to save this file like all the time. And so what I'm going to do is I'm actually going to write my own fixture to make things easier for myself. And I'm going to call this fixture right into file. And then I'm going to define it up here. And now the way a fixture works is whatever you return out of a pytest.fixture decorated function is passed as an argument with the name of the fixture to your test. So I just need to import pytest if I'm going to do that as well. And I'm going to call it right into file because that's what I passed to my test. And I'm going to give this fixture the temp path fixture. So fixtures can use fixtures. It's fixtures all the way down. And what I want out of this fixture is a function that I can pass a file name to, and it's going to write my little, NumPy file to that path. Now, so what I want out of this is a function. So I'm just going to call it my write func, and then I'm just going to define it right in here because I don't need it anywhere else. And it's going to take a file name, and then it's just going to do this thing. So there it is. And what this function is going to return to me, because what write func returns, I'm going to have access to once I've called it inside my test, is I'm going to return both the path where I've written, because I want to be able to read from that later, and I'm going to return the original data as well. And here we don't want just this literal, we want the actual file name that we're going to pass in. Okay, so when I try to use the argument right into file inside this test, it's going to be this function, and I'll be able to call it with a file name, save data, read it back, Bob's your uncle. And the benefit of this is that now whenever I want to write my little test data, I don't have to copy 3 lines of code. I get to just write one longer line of code. But I hope that you see at least that this could be useful to you. And particularly if you want to test data with different structures, like you want integers or you want a specific layer type or whatever, then those are arguments that you could pass to further customize your fixture. And so now that I've done that, I still want to make sure that I get a reader when I call it, when I call Napari get reader with my file. And I want to still assert that it's callable, although I guess I've already tested this, I could skip this. But what I want to do is I want to call that reader function on this file that I wrote and hope that it returns back what I think it should. And if you cast your mind back to the reader spec, it actually should return a layer data list. And I'm going to say that I assert its length is greater than 0. There's got to be a layer in there, otherwise I shouldn't have written it in the first place. I guess I should also assert that it is a list. You really, it never ends, you know, once you, I think I'll need to import that. Once you start testing things, yeah, there's a lot of things you can test. I guess you should try and focus on what's most useful, right? And then I want to test that inside that list is what I expected, right? So remember, it's a list of layer data tuples. The first item of a tuple, of the layer data tuple, is your actual data. So I'm just gonna do that explicitly. And then I'm going to assert, and here I'm actually going to use NumPy's asserting mechanism. I'm going to do testing.assert. As you can see, we've got all close, almost equal, approximately equal, etc. I'm going to assert that they're all close, even though I think they should actually be exactly the same. I'm going to assert that my layer data that I read back with my fancy reader function is the same as the original data that I wrote in. And if that's true, then we've got the full round trip. We saved the file, we got the reader, we read the file, and we should be all good. Cool. Now, one thing that I want to point out particularly about this is note that I didn't need a viewer to test this. I didn't even really necessarily need Napari to test this, right? And it's important that I didn't need that because I can't control Napari and I can't control the Napari viewer, right? What I can control is the code that I wrote myself. And by simply mocking some data and, you know, getting a temporary path to which I wrote that data, I was able to fully test my functions in a sort of enclosed way without having to rely on other people's code, without having to, you know, mock a lot of complicated objects. Okay, we've written some tests. That's super cool. How did we do, right? Are we done writing tests? Are there more tests to write? How do we know when we've written enough tests? This is where coverage comes in. So what I'm going to do is I'm going to install pytest-cov or pytest-coverage. And what this sort of PyTest helper is going to do is it's going to give me coverage for my tests. And what coverage is literally just the lines of code that ran when you ran your tests, right? And if there's lines of code that aren't running at all when you run your tests, then they could be doing who knows what. Maybe they're like a Bitcoin miner. So that's kind of an idea. It gives you an idea of like, okay, maybe this is a test that I should write. Maybe this is some code that I should write. And the way you run your tests with coverage is you still run PyTest, but instead of just PyTest dot, you add a --cov to point to the module that you're covering. And in this case, I'm going to generate a HTML report, and we're going to have a look at what that looks like. So it's still going to run the tests. It's going to get the coverage. And then it's going to say coverage HTML written to dear HTML code. And in here, in the directory where I run my tests, we've got this big long folder. But if we just grab the index and drag it into a browser, it opens up your coverage. And as we can see, we have 100% coverage. Well, we have 100% coverage of test widget because we didn't write anything. But it's the reader that we're interested in, right? So the reader file, which is the file where we wrote our reader code, has 86% coverage. And if I click on that, it's going to tell us, highlight for us which lines I didn't test. And the lines that weren't hit, they were never run at all during my tests, were the ones that are highlighted in red. So I never ran this code about path equals path 0, and I never ran this code about returns none. And what that means in logical terms is I never gave a list of paths, right? I never ran code that gave a list of paths, so I don't know what's going to happen in that instance. And I never ran code that doesn't return a reader, right? I never tested the fail case. And we can add those tests. And again, in the interest of time, I'm just going to copy them in. So the first one is get reader path. Okay, so we're just going to call it with a random file that doesn't end in .mpy. And we're going to assert that reader returned us none. And then we're going to call it with a list of paths. Here I've used the write into file fixture again, so we can write 2 files. And I'm going to call Napari get reader with 2 paths and assert that it still returns a callable. If I PyTest again, then that coverage report is going to be reran. And we should be able to see that coverage improve if we refresh the page. It's going to run right to the same folder. So we should just be able to refresh the page. Don't have to like drag it back in. All tests are passing, rock on. And as we can see, we've got 100% coverage now of our reader. Does this mean we're done? No. There could be lots of other more complicated cases that we haven't caught, but at the very least, we're running all of the lines of code. And if you are not super impressed with the HTML report, or you feel like it's a bit, I don't know, cumbersome or whatever, you can also print your coverage in terminal with cover report equals term dash missing. This is all in the slides. And what that's going to do is actually just print for each file the exact lines of code that you haven't tested, which at this stage is going to be 0. But there we go. So in the reader specifically, we've got 100% coverage. We didn't miss any lines. But in the widget, which we're going to turn our attention to next, we've basically missed like all of the lines, which checks out. So let's have a look at widgets. The widget that we're going to test is this super fancy threshold segmentation widget. And what it does is it takes some of the scikit image filters. If you've seen, if you were at the kickoff meeting, it's kind of a similar thing to that. I'm going to show you how it runs first, how it works, whatever. But basically what it does is it just runs a threshold, but some of the thresholds take histograms. And if they take a histogram, then we're going to give the user the option to just use the middle 90% of the intensity of the image, because, I don't know, we're just assuming that the extremities maybe, you know, don't tell you a lot about the image. So we're going to load our plugin just to show you how it works. It's called Threshold Images. We select the image. We have all of these filters. Now, when the threshold function takes a histogram, you've got this nice little checkbox. But when it doesn't, then that checkbox is like grayed out. We can't, because not all of them take a histogram. So let's see. So this is what isodata does without the histogram, but if we use the histogram, it does better, whatever. It sees more. So this is what our widget does, and this is what we're going to test. And that was just, you know, one of the ones that doesn't take a histogram. Now, this is the code for that widget. We're just building it specifically by subclassing Q widget, but we are going to show you a Magic Factory widget as well. I've completely blacked out these because we're not going to look at these methods. They're literally just adding buttons and stuff onto the GUI. But there are two pieces of like kind of cookie functionality in there that we are going to test. The first one is this checkbox that like enables and disables depending on what you've selected in your combo box. And the second one is the bit that actually does the thing with the excluding the outer, 10% of values and running the histogram and stuff like that, because that's kind of weirder. So how do we go about that? First, just a little bit of theory, a couple of like concepts for testing widgets in particular. The Make Napari Viewer fixture, which you get if you have Napari in your test environment when you run your tests, gives you a Napari viewer. If you need to add layers, if you need to change layer properties, stuff like that, you can do that with Make Napari Viewer, and I'll show you what that looks like. But in general, if you're testing widgets, you need a Q application running. You need a Q app running. I'm not going to get into what exactly that means, but trust me that you need it. If you're using Make Napari Viewer, you get it for free. It's like all inclusive. If you're not using Make Napari Viewer, you can pass the Q app fixture to your test instead. And again, you don't need to use the fixture, you just need to pass it in, and then you'll get a Q app. Or you can use Qtbot. Now, Qtbot is nice for a couple of reasons. It gives you a Q app. It gives you an add widget method. And if you add your widget to Qtbot, then it's cleaned up and closed nicely at the end of your test. And Qtbot has a lot of useful features for simulating widget interactions. So some of you I know are like desperate to like simulate mouse clicks and mouse drags and stuff like that. You can do that with Qtbot. So that's the theory. You need that Q app. And you can get it in a bunch of different ways, but there's 3 of them that are particularly useful. And QApp and Qtbot come with another PyTest helper, which is PyTest-Qt, which I've already installed into my environment. So let's test this widget. The first thing we're going to do is test this enable disable thing. And the way this basically works is just like if the current threshold isn't in the list of the ones that have histograms, uncheck the checkbox, disable it, change its color to be grayed out so it's obvious to the user, and otherwise just enable it. I'm going to just copy in the imports that we need. And what I want to point out about this widget is we've saved all of the bits and pieces, the history checkbox, the combo box, all of those are attributes on the widget. So we don't need to simulate that much. We can just make use of those attributes when we create our widget to check them, uncheck them, recheck them, create the context that we need to run our widget and to test it. Now I'm going to take Qtbot and I'm going to take Make Napari Viewer. Again, note they were not imported anywhere. They're just fixtures. If you call Make Napari Viewer, it gives you a viewer. And I've imported my widget from that other function. So I'm just going to call it, make the widget, and pass it the viewer. And then for good measure, I'm also going to add the widget to Qtbot. So it's closed properly. And then, again, just in the interest of time, I'm going to copy in some lines of code. The first thing I'm going to assert is that the current text is ISA data because that's the first threshold, and that the history checkbox is enabled because I know that the ISA data filter, the threshold is one that takes histograms. And then what I want to check is I want to check that it actually disables, right? So when it should. So I'm going to check the history box just by calling set checked. And then I'm going to change its current text, the current text of the combo box, to a different filter that I know doesn't take a histogram. And then I just need to check that it's no longer clickable and that it's no longer enabled and checked. And so I just assert that it's not that. And what I want to like specifically highlight about this test is that I didn't need to open the doc widget. I didn't need to like go into the plugin menu and open it. I only needed the viewer to pass it to the segmentation widget. And realistically, I could have just passed in a mock object there because I'm not using it. But it's not my job to test that Napari is going to correctly load this widget. It's just my job to test that this funky functionality that I've got about enabling and disabling works. So if we run this test, let's close Napari first and rerun our PyTest. Unfortunately, Qtbot is a bit slower. We're getting there. Yeah, and you can see that our coverage has immediately went up to 70%, and that's because we've actually built a widget and done some things with it. Now, the final test that I want to show about this widget is kind of a kooky one, but I want to show it because, again, you can create, I want to show that you can create the context that you need to create to test the things that you want to test. And so I'm going to just copy in this handy fixture that literally just returns an image layer. It's kind of a gratuitous fixture, but let's just do it. And then I'm going to copy in this large big text. And then we're going to go through it because this one's a bit big. So the weird thing about this histogram thing is that it excludes those end 5%, right? It doesn't take the lower 5%. It doesn't take the top 5% of values. It just takes the middle 90%. And I want to test that it's actually doing that. And so rather than, you know, trying to like get into the function, I'm going to generate data that is going to be super obvious and super easy for me as a human to work out that it's correct. And so I'm just building it again and adding it normally. And what I'm going to do is make an array of 5 zeros, 45 ones, 45 twos, and then 5 hundreds. And those hundreds are so big that if I'm not excluding the end 5%, if I'm not excluding those hundreds, my threshold is going to be super big and I'm not going to see anything. But if I'm not excluding, if I am excluding those big values, then the only label that's going to be left are the twos and the hundreds. And I can test that really easy because I can just go, yo, does this labels layer just have one label in it? And is it where the big values were? So here I'm just, again, just creating the image that I want. I'm not loading it from anywhere. I'm just being like, look, just generate this, you know, dodgy image. And then, again, I'm not opening the widget. I'm not clicking buttons. I'm just calling that method. I'm just calling the method that does the actual segmentation with an image layer and the threshold function, which, thanks to PyTest, I've parameterized so that we're going to test all of the ones, all of the thresholds that use a histogram. And then I'm going to assert, of course, that I get some labels back from, I get some labels, sorry, added to the viewer at the end of this function. So we're going to make sure that there is a layer in there and it's got data and its shape is correct. I'm going to assert that the only values in this label layer are 0 and 1. There was just one label that was found. And where in the original image it's greater than 2, we're going to put a 1. Otherwise, we put a 0. Okay, so we're just going to replace all of the big values with the label 1. And then I just need to assert that these two labels that I've, you know, concocted purely within the test is the same as the labels that were added. Without worrying about the GUI at all, because what I'm testing here doesn't care about the GUI. It's not about the GUI. It's about segmenting with this histogram. The final test that I'm going to talk about is a magic GUI widget, right? So let's say we've got a widget here. This has gone extremely over time, and I'm very sorry. This Magic Factory widget takes an image layer and a threshold, and it doesn't do anything fancy, it just runs it. How do you test a Magic Factory widget? Well, the benefit of Magic Factory is that what it returns can just be called as a function. The return value of your widget is just something that you can call and test your function, right? So here I've imported segment by threshold, which is just the Magic Factory decorated function. I call it, I get back this widge thing, whatever it is, and then I can test it purely by calling this widget with parameters that match the parameter types I've annotated. Okay, so it doesn't matter to me that these are going to be turned into GUI objects. They're going to be turned into combo boxes and checkboxes and whatnot, because I have access to the thing that just runs my function. So I'm able to just run my function and go on my merry way and make sure that what's returned out of that function is exactly what I was expecting. Finally, these tests need to be run on CI. My strong recommendation to you is that you use the cookie cutter, which is already set up for tests to run on GitHub workflows. But the way they work is, first we have a tox file. The point of tox is that it allows you to specify different Python environments and different platforms, and orchestrates your test dependencies as well. Again, if you just use the cookie cutter, this is already there. But the point is that at the end, once it's done the environment generation and specified your platforms and your dependencies and everything, it's just running PyTest. Once it's done with all of the setup, it's just running PyTest. And where is tox ran from? It's run from the workflow. This is the workflow that comes with the cookie cutter. I have changed it in 0 ways. It sets up a matrix again of the platforms and the Python environments. It installs all of the things you need to install to run Qt. Some of them are a bit tricky. I don't recommend that you go into the depths of it. Use what the cookie cutter gives you. And then it just runs tox. Okay, so the workflow runs tox, and then tox runs PyTest, and that's all you need to know. Copy this, use this, and then how it works is you make a branch. We're going to commit all our new tests. That we've just added. Pre-commit's going to run. Hopefully it fixes everything. And then I'm just going to push to my branch. And as soon as I push to my branch, this workflow is configured to run on all pull requests to main. So as long as I just open a pull request into main, this workflow is going to kick off. And it's going to kick off on all of the, as you can see, it's going to kick off on all of the matrix items as declared here, right? So Ubuntu with 3.7, 3.8, 3.9, Windows with 3.7, 3.8, 3.9, etc. And that configuration is defined in tox. That's it for me.
Thank you, Draga. Any immediate questions on that before we transition into a couple general topics? All right. I mean, of course, you can keep entering stuff in the chat. I'll monitor that. So yeah, let's see, I'll just say ahead of time that this probably, if I go through what I had planned, we'll go over time. I don't mind if you got to go just leaving. I will mention that the slides I sort of made here are filled with a lot of links. So mostly this is like a fire hose of stuff that I think might be useful. You can kind of just download the PDF of this afterwards. So I'm going to rush through a little bit of this, but the point really is to not like finish your education, but just direct you to some places. Some of this certainly you will know, depending on your experience, others maybe not. And then at the end, yeah, like I said, I'll probably stick around till like 2, and you're welcome to stay after and ask questions and stuff. And at the end, I have some of the questions that were gathered in the Google Doc that I'll just directly address, if time permitting. So I just want to make a brief comment on virtual environments. Many of you are probably very familiar with this, but just want to emphasize the importance of doing what you're doing in virtual environments. So probably like the number one problem when we have sort of bug reports come in, it's like, an environmental hiccup, and clearing and creating a new environment was, the answer. That's not to say we don't have plenty of bugs, but just want to really emphasize the importance of virtual environments. I'm gonna skip through this and actually mention that I gave like a 1.5-hour lecture on just general intro to Python and virtual environments. You can find it at this link. Sort of just discusses like what's the difference between conda and pip, what's the difference between conda and pyend, and all this sort of stuff. So I'm not going to go into that here. I would just sort of implore you to make sure that you are comfortable using virtual environments and that you're clearing them and making new ones when weird stuff happens. The general overview that I would recommend, if you're just getting started, is use Miniconda or MiniForge. MiniForge is just Miniconda pre-configured with the CondaForge channel. CondaForge channel is super important. The default channel, we see this a lot, the default channel has some really outdated packages. Specifically, the newest version of Qt it has is 5.9, and Napari doesn't even support that. So if you just go ahead and install Conda and you don't use CondaForge channel or anything, you're very likely to have problems, and so are your users. So just be aware of that. If you want to read a little bit more about it, you can click on this link when you get these slides. There's some discussion there. I am monitoring the chat, so feel free to type stuff in there if any of this is triggering questions you knew you had. Yeah, so I would just say, like, main lesson, create environments liberally. Conda create name of environment, add a Python or a version of Python that you want to use, activate it, and then go nuts. You can install using pip into Conda environments. You can install using Conda into Conda environments. The one thing to sort of be aware of is if you combine pip and Conda, you have a possibility of some binary incompatibilities, and the most common thing is Qt. So if you use Conda to install Qt and then you pip install PyQt, you may well run into problems there. So just a heads up on that. And if you run into problems, you can try to fix them, but really I would say consider these as disposable and just nuke your environment and start over. So I have this sort of, activate my base environment, remove the environment, create a new one with the same name, reactivate, and then pip install. I have like that on scripts because I just do this so often. So that's the main lesson here, is just consider these disposables and encourage your users to do the same thing. You can really waste a lot of time trying to debug something if you don't say, did you try this in a fresh environment? If they can reproduce it in a fresh environment, then it's definitely worth debugging. So some comments on deployment. For instance, it often gets asked, should I deploy to PyPI where you can run pip install, or should you deploy to Anaconda where you can run conda install? I guess I would say, both is always nice, but for now, I would prioritize pip. There's a lot of caveats and side rules here, so none of this is set in stone, but the main reason is that currently the built-in plugin installer and the Napari hub will only be monitoring PyPI, the pip repository for packages. So that's not to say you can't use Conda only, but you will need to basically provide your users with manual installation instructions, walking them through running Conda install your package. This is definitely subject to change in maybe the near future. We're working on new bundling strategies to support Conda. Support it within the built-in package installer. So this is the, if you go to the plugins menu and you try to install a package, that's the thing I'm talking about by the built-in plugin installer that currently won't look on Conda. So I'm gonna kind of breeze over this. I was gonna talk about briefly the difference between source disks and wheels. The point is there's two broad ways to package your project. One is as a source distribution, which really needs to be built still. And the other one is called a wheel, which is a pre-built package that's kind of ready just to drop into the site packages folder. When this becomes really important is if you or a dependency is using C extensions. So if you have code that needs to be compiled, this is the exception more than the rule, but if you have like C code or other code that you need to compile, it's really important to ship a wheel with your package. Otherwise, people people will pip install, it'll try to build a wheel, and that may fail depending on your dependencies and the local user environment. So most important thing is just to, generally, if possible, ship both sdist and wheel. And I'll talk about that in the next slide. This really goes for your dependencies too. So I would, maybe one lesson here is definitely be frugal with your dependencies. Each new sort of dependency you consider adding to your setup config should be given some scrutiny. You should ask, how easy is it going to be for people to install this? If you use something really complicated that only goes on Conda, that means no matter how simple your package is, it is also now no longer easily installable. So that sort of goes without saying, but just worth mentioning. And to see if a package ships a wheel, like how do you know this? Generally, go to PyPI. So here's an example of Napari. If you just go to pypi.org and you go to download, there are other ways to do this, but one is to go download files. And if you see something, a wheel, and for Python 3, you're fine. That package offers both a source distribution, an sdist, and a wheel. So we're good there. But the standard deployment process on PyPI is generally a combination of two steps. One, you're going to build the package, and I'm suggesting that you use the package now called build. It's pip install build. Documentation here and usage down here in a second. And then Twine. Twine is a client that lets you upload your built package to PyPI, where it can then be pip install. So really, it's just like a 4-line process. Obviously, this is hiding a lot of complexity, but generally, we're going to install these two packages. We are going to run this command, python m build, and this will create both the wheel. By default, you can configure this. We'll create both. Side note here, python m build is sort of the modern alternative to setup tools, Python setup py, sdist, bdist wheel. So if you're used to using Python setup py, this is a replacement for that. You can still use that, but this is sort of this is where the packaging sort of environment is going to what's called the PEP 517 standard. And I won't get into that, but build is an alternate to this. And then we're just going to Twine upload. So optionally, you can upload it to some test PyPI to make sure everything's good. But really, at the end of the day, it's Python m build, Twine upload dist star, and that will do what you need to get it to PyPI, and it will error if you've got problems in your metadata. You can do this automatically on your GitHub Actions. So this would basically entail, I'm sorry, we don't really have time to dive deeply into GitHub Actions, so we're assuming a little bit of knowledge there. We could perhaps do another thing on what is GitHub Actions, but at the end of the day, usually this entails putting some file in your repository .github/workflows, some file. And this is the syntax here, and basically here we have a job that deploys our package. I'll get to this in a second. And it's just going to check out our package, install Python, run these commands, pip install build Twine, run Python build, and then Twine upload dist. And I'll note here that you will have had to add like a secret key to your repository, so PyPI recognizes your upload, but that's actually described in the cookie cutter README. The other thing you can do is use a pre-made GitHub action. So here's a link you can click on, read their docs there. This is basically designed to kind of do this for you. A really important thing here, though, is you should gate this action on some criterion like a git tag. So for instance, you don't want to just run this every time you run a job on GitHub. You might make sure that your thing starts with a tag. So only run this on tagged versions. And for that, here's a link you can read about gating various jobs on certain conditions. All right. The other way is Conda. I'm not going to step through this. If you want to put your package on Conda, I really recommend using Conda Forge. They have an incredible build process. It takes a little learning. All of the docs are right here, adding packages to Conda Forge. It involves forking a repository, creating a new folder in the recipes directory, and modifying the meta YAML to for your package, and then you open a pull request. After you do that once, it's really easy to keep updating, and it's actually far easier if you already have your package on PyPI. So I generally recommend start with PyPI, and then if you want to also put it on Conda, it actually is quite easy once you already have it on PyPI. Side note here about version management. The goal with version management, what we mean by version management, is you want to make sure that you're bumping your package's version everywhere it may appear. That's like in _init, the dunder init, also in the metadata, right? If you have written your version, preferably you will single source your version so it's only written one place. But the most important thing here is that you don't have, get these out of sync. There's a lot of different ways to do this. One of the options we offer in the cookie cutter is this package called Setup Tools SCM. And really, there's sort of three ways to do this. I'll talk about them each. Setup Tools SCM uses git tags. So the idea here is after you have configured this in your PyProject Tomo, one of your package metadata files, all you really do to bump your version, prior to, when you're ready to release, you would say, okay, this is the version I want to release. This is the commit I'm happy with. You would say git tag, give it a new version. And if it starts with V like this, then basically this project, Setup Tools SCM, will inject into all the places in your code, your init file, your package metadata, everywhere, that version number. So it's sort of the most amount of magic, but it's the least amount of work. So if you are comfortable with it and you read that, this can actually be a super easy way to bump everything at once. And so the next time you run build or install, your version will sort of auto-magically just be whatever the most recent git tag is. You can do this manually with scripts. So there's bump to version is a thing that you configure it, and then each time you're ready, you would run this bump to version, and you tell it what the current version is. It's not what you want it to be. And then what you want it to bump. Like here, minor, this would turn it from 0.51 to 0.6 because that's a minor bump. So this is a local script. And then lastly, you can do this manually. Not recommended because you will eventually make mistakes where you release a package whose version, if you import it and ask what the version is different than what the metadata is. So really, I encourage you to get comfortable with one of these two. But maybe the take home here is the best thing is the one you actually use. You really want to get comfortable with at least one workflow for bumping the version and deploying your package so that it feels almost effortless. Otherwise, you won't do it and you'll just accumulate bugs and never bump. So there's a gazillion tools. Hopefully, we gave you some links there. We can answer more questions, but the most important thing is just maintain a single version and get comfortable with bumping and deploying. That was all I really wanted to say about deployment. Any questions on that before I move on to some dev tips? Okay, I will keep going. Okay, this bit is the most fire hosey, and I'm actually going to spend the least amount of time. The key point here is everything I'm about to show you in the next two slides is optional. These are helpful, but they each take a little bit of time to learn. This is one of those things where the more time you spend coding, the greater the return on investment for learning each one of these. But it's definitely a personal decision, if the time saved by using these outweighs the time required to learn them in the first place. So all I really want to do is give you a list of things we have found useful, briefly what they do, and where you can read more about them. So in the cookie cutter, these are some of the dev tools that we include. And they broadly fall into two categories. One is linting tools. These like check your code for various things, like that you haven't left an unused variable or an unused import or something like that. Just code quality things that you want to be automatically told about as you're going. And these integrate nicely with your IDE, your developer environment, like VS Code or PyCharm or whatever you're using. So, all of that requires a little bit of how do I get this into my IDE? And I recognize that's like a whole lecture in and of itself. So maybe if you're not already familiar with these, just know that these automated checks exist. They can be super time savers, but it does require this investment up front to get them all installed. Flake 8 is a code style convention for things like unused variables, line spacings, etc. We use Flake 8 a lot. MyPy is probably the hardest one to use, but probably the most useful. It is a type checker, which basically checks, if you say x equals 1, and then you say, x dot split, trying to use like some string method on an integer, MyPy will yell at you for that. It will say, without even running PyTest, MyPy will say you used this type incorrectly. And you can annotate things as this is what this type is, and it will make sure you're using your types correctly. It's static. It doesn't actually run any code. So again, super useful once you get the hang of it, but definitely like an intermediate tool. It goes a little bit against some of the philosophy of Python should just be super dynamic. And but I would say that along with high test coverage, this is probably for me the biggest time saver and project robustness tool that I use. So big investment, big reward. Formatting tools actually modify your code. So things like Black is a very popular code formatter. It's just something you run Black project, and it will basically reformat all your code. So the first time you run it, you're going to have a shitload of lines changed. But the benefit of using something like this is that there's only one way it will then be formatted. And when people make PRs to your repository, you don't have to sort of agree on what indentation is going to be. It just picks it for you. You may not always like it, but it's sort of nice to just have this is what our style is. AutoFlake performs some of these Flake 8 checks automatically for you. Again, all of these will actually modify your code, and you need to check in the results yourself. iSort handles your imports at the top, making sure they're clean and pretty. Setup config format, just make sure your setup config is pretty. So there's many more you could find if you wanted to, but pre-commit is a thing you should know about. Pre-commit basically runs all of these checks, whatever it is you have chosen to activate, each time you run git commit. And so this is handy to basically prevent bad code from ever getting checked in the first place. The gist of this, here's the link if you want to read more, but the gist is basically you install it, and then you run pre-commit install. And what this installs is a git hook that basically says, every time I run git commit, I want you to run pre-commit for me. And pre-commit will then go and look in your configuration, which is this file, pre-commit config, all described up here. And that file will be a list of, I want you to run Flake, I want you to run MyPy, I want you to run AutoFlake, etc. It will do all that for you. The question is, does pre-commit run automatically within an IDE like PyCharm when using Git via the GUI? Yes, it does. So most of these IDEs will look at your .git folder. They'll look at your repository for your Git config, and pre-commit is actually installing directly to your Git config. So assuming PyCharm and VS Code are being good citizens of running Git, then the answer is yes. It certainly works within VS Code. And if you want to run this manually, you can run pre-commit run. And so this is just a good way to keep, once you've decided these are the principles of code quality I want to have, then it's a good way to do it. Somebody is suggesting they would do pre-commit manually in CI rather than pay for GitHub Action. Okay.
Pre-commit CI is not free because I looked at it recently.
It is free. I've used it on all my projects and I've never paid a dime.
Well, there was some feature I was looking at that wasn't free.
It might be if you have a non-public repo.
Yes, that's it. That's it. If you've got a private repo, you have to pay for it. So I didn't use it.
That is a generally true thing for a lot of these services. So many of these free services will say if you've got a private repository, you got to pay. If you public code, you don't. So that's often true. But absolutely, if you have a private repo, you don't have to use pre-commit. You can run this thing manually in your thing. If you have a public, this is super useful. It's actually much faster because it caches everything, and yeah, handy. So those were all generic dev tools. A couple of Napari plugin specific things to be aware of. These are very much works in progress. Know about them. They're minimal at the moment. They're not harmful. They just don't do a ton. One is Napari plugin checks, and the other is Napari plugin action. The first is a pre-commit hook. This is something you would add to your pre-commit config, like this right here. And it will, every time you run git commit, statically check various best practices of your plugin. For instance, actually, I'll get to those best practices, but some health things about like Qt and other things like that. Napari plugin action is a GitHub action. So this is something that is intended to be added to a GitHub workflow. This currently checks things that like your plugin is installable. And actually, you'd be surprised, we did some of these automated checks, and maybe like 25 to 30% of the plugins were not installable, period, meaning they made some assumptions about the environment they were going to be installed into, and they didn't declare them specifically in their setup config. So for instance, if you use Napari's API in your plugin, it might seem a little unintuitive, but you should declare Napari as a dependency. For instance, if you import Napari anywhere in your plugin, then you depend on Napari. And it maybe seems obvious. I've written a Napari plugin, of course I depend on Napari, but not all Napari plugins actually need to import Napari. And if you don't need to import Napari anywhere, that's great. You don't depend on Napari. You are intended to be used with Napari, but your package does not depend on it. So this action will just check many things like that you actually are a valid package that can be installed and imported. And it does a few sanity checks about Qt backends and doc widgets. So this one is more of a work in progress, but that's what that's for. Okay. This one, some really important stuff here. It's well described on this page here. So I'm just going to bullet point and encourage you to go here for more. Do not include PySci2 or PyQt in your package dependencies. This is the biggest one. So we want you to use QtPy, which is a backend agnostic Qt importer, and let your users pick the backend. So basically, this does mean that your package basically will not. This is the same problem Napari has. If you're familiar with the Napari bracket all syntax or Napari bracket PyQt syntax, that's saying install Napari and one of these extras that installs a Qt backend. The real thing we're trying to do here is allow anybody to use either PySci2 or PyQt as their Qt backend. And this requires a little bit of finagling and stuff to do. But if you include PyQt5 in your plugins dependencies, then pip will install it, even if they have PySci2 installed. And that can very often lead to problems, particularly if they have one of them installed with Conda, and then pip goes ahead and installs it with pip. And you literally can break your user's environment, and we've seen it happen all the time if you do this. So while it adds a layer of frustration, because now it basically means you need to manually encourage your users to install their own backend, it is really, really important if we are to maintain this backend agnostic capability. I will monitor the chat if there are any questions on that, because that one is certainly a big one that gets a lot of questions. Try not to depend on packages that require C compilation, but do not offer wheels. So, many of the scientific data ecosystem uses C to speed things up. That's great. But if they don't, offer wheels on PyPI, then it basically is going to make for an uninstallable package for at least a solid percentage of your users. We've seen this a lot, and they run pip install, they get this wall of red text because they don't have a compiler installed locally. So this goes not just for your packages, but your dependencies, and it's just a really tough one. If they don't offer wheels, but you must use it, I would like try to get them to build a wheel. It's a big one. Don't import heavy dependencies greedily at the top of your module. This used to be a big thing, less so with NPE2, because NPE2, the new plugin engine, is not going to import things immediately as the old one did. I'm going to gloss over that. Don't leave resources open. This is like basically use this, context managers like with open as file handle read, and then close the file handle, as opposed to something like this. The reason not to do this one is if someone actually tries to uninstall your plugin on Windows, and your package has something like this, Windows will refuse to uninstall, but it will like partially uninstall, and basically you'll have a broken environment. So this is something to avoid. And as Draga so nicely demonstrated, definitely aim for good test coverage. Okay, so that's good. That wasn't so bad in terms of timing. As I said, if you need to go, that is fine. But what I'm going to do next is start digging into some of the questions that we got on the Google Doc. I will also monitor the chat. And actually, I'll pause right here if anybody wants to unmute themselves and ask anything, or ask in the chat. Or go. This is fine too. I won't be offended. Okay. Again, these questions will also be in the PDF that I'll upload, and links. So I'm just going to address some of the things that people asked. Some of them were definitely like too big for this, and we'll have to address later. But somebody asked, best practices to test a plugin with multiple sequential steps. In other words, is it okay to rely on the results of a test to run the next test, or should they be all fully dependent? And really, ideally, they should be fully independent. The test shouldn't pass or fail together. The key here is to use fixtures to generate test inputs. So whatever you would have expected the previous test to output, and you need that as your input to the next test, make a fixture that pretends to be that output and give it to your next. Don't expect the first test to pass giving something successfully to the second. That you'll certainly get a failure when you get something wrong, but you won't see perhaps exactly. You'll have some false positive failures. So fixtures are great to basically provide inputs to tests, like injecting sort of halfway into this pipeline, so to speak. And then mocks are another super useful thing. Mocks are complicated. The docs are here, but a mock is an object that lets you basically pretend to be some object, and it will let you say assert that specific calls are made without necessarily caring what happens when that call is made. So for instance, if you're using, a common example is if you're using like a remote API, and you don't want your test to depend on the internet, for instance, you can just use a mock to assert that you have called out to the API as you wanted to, and then you just kind of assume that the API is doing the job as it needed to. So mocks and fixtures are really good for this. Definitely an art form, takes time, be patient, but this is the goal, in my opinion. How to test widgets, Napari viewer. Draga talked about this a lot, and I would just like, the one thing I would reiterate is kind of try not to test the GUI as much as possible. So basically, to test methods as directly as possible. If you look at your code and say, just look at a method and say, what is this method doing? It takes this in and it has this result. If it's not strictly like, try to test as much without testing like the visual effect or some user interface on clicking a button. If you do have scenarios where you're actually creating a complicated thing, then the PyTest QT thing that Draga mentioned is great. Here's the docs to that. And oftentimes this really does just come down to knowing the Qt API really well. There's a lot of like, the only way to assert many of these things is to know how Qt does it under the hood. So that is unfortunately just part of the learning process there. Somebody asked for better signal slot documentation as the user interacts with the core Napari interface. Totally get it and agree, we need to improve this. I did want to point to this in case you hadn't seen it. So the events reference is basically a list of all the events that various objects in Napari will emit that you can connect to, what they correspond to, and the type that you of the value in the object. So I would say, if you haven't seen that, that's where we intend to document these things. And somebody specifically gave the example, for example, creating and deleting a point or shape layer. Most of that is going to be, this isn't really a direct answer, but So for instance, if somebody just creates a point object, you don't really get to know. There is no event. Points have been created, and I think we would probably keep it that way. What we really care more about is like the interaction, because points themselves like are not eventful. They're just like Python objects. What we really care about is like, has this thing been added to the viewer? And that's the point at which we give you hooks to know. And so viewer layers events inserted. That will tell you, hey, somebody's added something to the viewer, and you can check, is it a points or shapes layer? Same with removed, moved, changed, reordered. Editing was mentioned. This is super hard because it may be a pure NumPy object. So if somebody goes layer.data, indexes in and changes something about that, that is not a Napari object. We currently aren't like spying on NumPy objects. There's some issues open about this. It's a challenging thing to do, to basically inject evented programming into a library that we want to natively support, but we don't want to monkey patch too much. So it's tricky. We recognize this is a big one. Like we do sort of need to know these things, so it's an open discussion. Somebody asked how to avoid GitHub tests failing. I'm not sure how to answer this one other than to say, please make sure that your tests are passing locally first. If they're passing locally and failing on GitHub, it happens. It's complicated. It is really sort of very case specific, and I think I would need to know more there. Still monitoring chat. Okay, make process cancelable. This one is sort of not. So the question is, how do I make a process cancelable to interrupt? For example, if I'm running it in a for loop, and I think this has a lot of answers, so I wouldn't presume to be able to answer, generally speaking. I would just say, if you're in a single threaded thing, like you haven't used threading, you haven't used processes, there really isn't anything unless you sort of specifically program it in there. But if you just use Control-C, you will stop a for loop. This is a keyboard interrupt, and so that's a great way to do that. In Napari, though, I assume you sort of mean I have a long-running process and it's got a for loop, and I want to be able to, within Napari, without stopping everything altogether, cancel. And here I would encourage you to look at the generator-based thread worker pattern, and this is the link there. This is a big topic, so I don't want to really belabor this, but most of the time, if you have a long-running process that you want to be cancelable, consider using the thread worker decorator, described here, and use a generator that yields from time to time. If you have a generator that is yielding back to the main thread from time to time, that gives Napari an option to cancel it. Somebody asked, are there testing environments in Napari? I don't really know what the intention of the question is. I will say Napari itself does not create or otherwise manage environments. So there is no, we don't create environments. If that person is here and wants to clarify either in voice or chat, I will be happy to answer that, but. Okay, then this was like, are all reader functions run on a separate thread by default? No, actually, so nothing is threaded in Napari by default. This is, probably a limitation someday, and something we are going to need to like deal with to truly, like things like VS Code, for instance, run all extensions in a whole other process altogether, and it's, a lovely way to be robust to failures and stuff, and we don't have that. So no, the answer to that is, at the moment, all threading basically is up to the plugin developer or the user. We have tools. If you go to this page on threading, we offer some tools to make threading easier, but nothing is threaded by default. You have to opt into that. Is there a standard way to keep track of the layers your widget creates? Yes. For example, a widget creates a layer, adds to the viewer, and then monitors for that layer to be removed. If it's the same layer, do something. Oh yeah, okay, so this one, the big thing, I'll type it in here, the big thing to know about is the layer.source attribute. So layer.source is an object that has, like, if it came from a file, like if somebody did viewer open file, that'll be in layer.source. Layer source may also have .widget. So if it came from like a Magic GUI widget or a widget, a doc widget adds this may only work for Magic GUI. I'm not sure. I need to double check that. But I would say that layer.source is really the intended attribute for that. And if you find that layer source does not meet the specifics of your thing, open an issue, because that is the place we want to put that sort of stuff. This is a big one. So then there was sort of like other things you might ask, maybe in future things. This is a big one. I suspect many of you might have come to this expecting to learn more about the Napari plugin engine 2 and how to migrate to the new plugin architecture. We can do more on this. This is brand new. We're happy to dig into this. I'll just mention that for now. The primary difference in the old and the new methods is that NPE1, Napari plugin engine, used decorators to find your plugin's contributions. So anybody who's done this is familiar with the pattern. You ran from Napari plugin engine import Napari hook implementation, and then you decorated Napari get reader or Napari provide experimental doc widget or something like that. And the big problem, and I mean, the way that worked is that Napari had to actually import your plugin to find your stuff. And if you imported, say, TensorFlow at the top, we have to run through everything. Importing is potentially very expensive, and as soon as somebody gets like 5 plugins, the whole thing can kind of get really slow. So the major change here is that NPE2 uses static manifests, like an additional file, napari.yaml, that you will include. And this describes your plugin's contributions without requiring import. This manifest will sort of tell us all the things you offer and where we find them, so that if somebody, say, goes to the plugin menu, it'll see all your stuff, even though we haven't executed any Python code. And when they say, give me that widget, then it goes and imports. And if there's an exception at that time, it'll be clear that it was that plugin. But that is the major difference. So no more decorators, and now you use a static manifest. I'll point you to these. The plugin docs were just recently updated, like this week. So have a start there, and the migration guide specifically is here. There is a tool. You'll pip install NPE2 and then use NPE2 convert. Just put that in the chat. NPE2 convert to help migrate plugin. Okay. Actually, this is the last question I had. And it's 2. So I'm going to end with this. This is a really good question, and it comes up a lot. There's a lot of answers to it. But what is the optimal setup to quickly iterate in widget development? I suspect many people are sort of, you make a plugin, you pip install your plugin, you run Napari, and then you go to plugin open, and you start manually, and then you make a change, and you have to do that all manually again, and that's a real pain in the butt. So there are many ways to attack this. The biggest one I would say is just create a simple script that will do what you did. Anything you're doing manually, just try to make a script that you can do it. So create a script that will start Napari and load your widget without any UI interaction. So this might be yeah, I wish I had more examples of how to do this. It depends on what you're trying to do, but the real point here is ping us on Zulip, ping us on ImageSC, ping us on GitHub, say, how do I do this automatically? I'm doing something manually and I don't want to. The biggest one here is for a widget, for instance. Don't really test your plugin as a plugin. Test it just as a script. Like basically manually create your widget, and then use viewer window add doc widget to manually add it to the thing. And don't go through the plugin infrastructure at all at first. And only once you're like, yeah, this is working, then now you've got a plugin. And the last 2 things I'll point you to are auto reload is an excellent. IPython has an auto reload extension, which, as long as you're in IPython, will monitor code for updates and then re-import that code. It's a little tricky to use. Some things work better than others. Some things work amazingly. Other things, sometimes it doesn't work and you wonder why. But auto reload is a very useful thing if you're like modifying code and wanting to see the results. It can work with widgets. It doesn't always work with widgets. it really depends on the lifetime of the object instance and like what you're modifying. So, whoops, screen share. So I would just say, yeah, be aware of auto reload. And then Watchdog has a thing called Watch Me Do. This will monitor a file or directory and then rerun the command each time. And so if you've done step one, where you create a script that will open Napari, add your widget, and do some stuff, it'll like set you up like to whatever you need to. Then if you run like watch me do and the name of your script or Python, then it's like every time you hit save on your file, yes, it does have to restart Napari and everything, but you don't have to manually do that. So these are maybe tricks I would suggest for rapid iteration. And with that, I will end. I know we've taken more of your time than we promised. And I will upload these slides soon. But is there any way to update the plugin without reopening Napari? It can be slow to keep on reopening Napari even with a script. Yeah, I mean, not really. The only way there would be the import lib reload. Like import lib reload, like you need to basically reload the module, and you can either do that manually or use IPython. It is a big topic, and let's like talk about that on Zulip because there's many answers. Yeah. All right.